Let's say that you've got some matrix C. I'm trying my best to bold it to make sure you realize that this is a matrix. And let's say that we know that it has A rows and B columns. So it's an A by B matrix. And let's say that we are going to multiply it by some identity matrix. Some identity matrix. Once again, let me do my best attempt to bold this right over here. So we're going to multiply the identity matrix I times C. And of course, we are going to get C again because that's the identity matrix. That's the property of the identity matrix. And of course, C, we already know, is an A by B matrix. A rows and B columns. Now, based on this, what are the dimensions of I going to be? And I encourage you to pause this video and think about it on your own. So we've already done this exercise a little bit where we first looked at identity matrices, but now we're doing it with we're multiplying the identity matrix times a very general matrix. I'm just even speaking in generalities about its dimensions. Well, one thing we know is that matrix multiplication is only defined if the number of columns of the first matrix is equal to the number of rows of the second matrix. So this one has A rows, so this one's going to have A columns. It's going to have A columns. So it's going to have A columns. Now, how many rows is this one going to have? Well, we already know that matrix multiplication is only defined if the number of columns on the first matrix is equal to the number of rows on the second one. And we know that the product gets its number of rows. We know the product gets its number of rows from the number of rows of the first matrix being multiplied. So if the product has A rows, then the identity matrix right over here has to have A rows. Now, what's interesting about this? When we first got introduced to identity matrices, we were multiplying. We picked out a 3 by 3 example, and we got a 3 by 3 identity matrix. What's interesting about what we've just proven to ourselves is the identity matrix for any matrix, even a non-square matrix. A and B could be two different values. The identity matrix for any matrix is going to be a square matrix. It's going to have the same number of rows and the same number of columns. And so when we think about identity matrices, we can really just say, well, is this the identity matrix that is a 4 by 4? Is it a 3 by 3? Is it a 2 by 2? Or I guess even a 1 by 1? And so so the convention isn't even to write identity 2 by 2 is equal to 1, 0, 0, 1. The convention is actually to just write I2 because it's going to be a 2 by 2. It's going to be a 2 by 2 matrix, so it's going to be 1, 0, 0, 1. Identity 5 is going to be a 5 by 5 matrix, so it's going to be 1, 1, 2, 3, 4, 0, 1, 2, 1, 2, 3, 0, 0, 1, 1, 0, 0, 0. You get the idea. 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. Just like that. The whole point here is just to realize that your identity matrix is always going to be a square matrix. And it works even when you're multiplying non-square other matrices.